Hello everyone, welcome back to my channel. Today's video, we are going to learn about hashing algorithm, one of the most important concepts in data structures. We will cover what hashing is, why we use hashing, what hashing function is, and the concept of key and values, how insertion and retrieval works, and what collisions are, and one simple way to handle collision using chaining. So let's get it started. Now, let's start by understand what hashing actually is. Hashing is a technique that could help us to store and retrieve data very quickly. Instead of searching through every piece of data one by one, hashing uses something called hash functions to calculate the exact location where the data should be stored. And the data is stored inside a structure called hash tables. You can think of a hash table as a collection of numbered storage locations. And the hash function decides which location should hold each piece of data. The main purpose of hashing is to improve efficiency because the location is calculated directly. Operations like inserting, searching, and even deleting data become much faster. For example, imagine a university database with thousands of student records. If you search each record by one uh, to find a student, it would take a time. With hashing, we can calculate the correct location immediately, making the search much faster. That's why hashing is widely used in databases, programming languages, and many software applications where fast data access is important. Let's look at the most important part of it, the hash functions. The hash function is a mathematical formula that converts a key into an index in a hash table. In simple terms, it calculates the exact position where the data is should is stored uh, in a hash table. One of the simplest hash function is the key modulus by table size equal to index. Here, the key is data we are working with, such as student ID or product. The table size is the total number of positions available in the hash table, and the module operation return the remainder after divisions. And that remainder becomes the index where the data is stored. Uh, let's look at an example. Suppose our table size is 10 and the key is 25. When we divide 25 by 10, the remainder is 5. So 25 modulus 10 become 5, which means the data will be stored and at index 5 in the hash table. Whenever we need the data again, the same hash function performs the same calculation and take us directly to the index file. This direct access is what makes hashing is so fast and efficient. Now that we know how the hash function calculates an index, and let's understand two important terms used in hashing called keys and values. First, we have the keys. A key is a unique identifier that's used to locate or access data. You can think of it as a label that identifies a specific piece of information. Common example of keys are student ID, an employee ID, or product ID. Next is a values. A value is actual data associated with that key. Uh, it is the information we want to store or retrieve. Let's look at simple example. Suppose the key is 25 and the value is John. Here, 25 is used to identify the record while John is actual data being stored. When we apply the hash function to the key 25, it calculates the index where the value John will be stored in the hash table. So, whenever we use the key 25 again, the computer can quickly locate the correct index and retrieve the value John. In simple terms, the key tell us what to look what we looking for, and the value is the information we get back. Now let's see how data is inserted into a hash table. In this example, our hash table has 10 positions. So we will use the hash functions for index equal key modulus by 10. So let's insert our first key 15. We'll calculate 15 modulus by 10, which gives us 5. So the key 15 is stored at index 5. Next, we insert 27. Using the same formula, 27 modulus 10 equals 7. So we stored 27 at index 7. Finally, we insert 39. So 39 modulus by 10 equals 9. So 39 is stored at index 9. As you can see, each key is placed directly into the calculate position. So we don't have to search for an empty locations or compare it with other data. The hash function tell us exactly where each key belongs. This direct this direct placement is one of the main reason why hashing is such an efficient method for storing data. Now let's see how retrieving data works. Suppose we want to find the value associated with the key 27. Instead of checking every position in the hash table one by one, we use the same hash function that we use to when storing the data. We calculate 27 modulus by 10, which is 7. This tell us that the data is stored at the index number 7. So instead of searching through all the indexes, the computer goes directly to the index 7 and retrieve the data immediately. For example, if the value stored with the key 27 is John, the computer goes to the index 7 and return John without looking anywhere else. This direct access is what makes hashing so efficient. In most cases, the finding data takes constant time. This means the this means that whether the hash table contain 100 records or 100,000 records, the retrieval process is almost equal fast, as long as there are very few collisions. Uh, there is one of the biggest advantage of using hashing. Up to this point, we have seen how hashing stores and retrieves data very efficiently. However, hashing isn't perfect. Sometimes the problem can occur. And this problem is called a collision. A collision happens when two different keys are assigned to the same index in the hash table. Let's look at the simple example. Suppose we have already stored the key 15 using our hash function, 15 modulus by 10, which is 5. So the key 15 is stored at the index 5. Now let's insert another key 25. Again, we apply the same hash function, 25 modulus by 10, which is 5. As you can see, both 15 and 25 produce the same index, which is 5. The problem is that index 5 can normally hold only one item. Since both key want to store in the same location, the computer doesn't know where to place the second key. This situation is called collisions. So, in simple terms, a collision occurs when the two or more different keys map to the same index number in a hash table. The good news is the collisions are common and expected, and there is several techniques to handle them. In the next slide, we look at one of the most common method called separate chaining. Now that we know what a collision is, the next question is how do we solve it? One of the most common solution is called separate chain. Instead of allowing only one item at each index, we store a linked list or simply a list of items at the index. Let's continue with our previous example. We already know that both 15 and 20 are mapped into the 5 instead of replacing one value with the other. We store both values together in the list. If we find another one with the same index, we simply add it to the end of the list. When we want to search for a key, the computer first calculate the index using the hash function as the slide. It goes directly into the index 5. Then instead of searching the entire hash table, it only checks the a small list attached to the index until it finds the correct key. So even though the collision has occurred, all the data is stored safely uh, and can still retrieve efficiently. That's why separate chaining is one of the simplest and most widely used technique for handling collisions in hash tables. Hashing is used in many real-world applications. Some common example it includes password storage, where password are stored securely using hash values. Database indexing, which allows the database to find record quickly. Programming languages like Java use hash map to store and retrieve data efficiently. Web browser use hashing for caching, and blockchain technology also relies on the hashing to ensure data integrity and security. As you can see, the hashing is used almost everywhere in the modern computing. Let's quickly review what we learned today. Hashing is technique used to store and retrieve data quickly. A hash function converts a key into the index. A key and it identifies the data while the value contains the actual information. Insertion and retrieval are very fast because the hash function tells us exactly where the data belongs. Sometimes two keys generate the same index, creating a collision. One simple way to solve a collision is a separate chaining, where multiple items are stored in a list at the same index. Understanding hashing is important because it forms the foundation of many advanced data structures and real-world software systems.